welcome to our second episode on this journey into contest mathematics for science competitions. Now, our topic for today is vectors and matrices, which are algebraic concepts which have an important role to play in geometrical analysis. As you may already know, geometry becomes an important part of both physical and chemical problems, which have many elements involved, taking advantage of concepts like symmetry or geometrical alignments or even trigonometry. So vectors and matrices will help us process these much more easily. So they are important for physics and chemistry contests.
But wait, why don't we see these before 11th grade?
That's a good question. Well, they don't become relevant until more complicated forms of equations, like systems of equations, get introduced, or even until we've mastered the forms of a line sufficiently to start exploring them as vectors, or maybe parametric or another component involved like that. Anyway, I don't want to get ahead of myself because we will be covering such concepts later on. For now, let's break down vectors and matrices in under 3 minutes.
Challenge accepted. Now, a matrix can be thought of as a two-dimensional grid of data. Now, imagine a rectangle filled with numbers and information inside it. Now, it has a fixed index, and we refer to matrices by the units in each dimension. For example, a 2 by 3 matrix can be thought of as a matrix which is 2 units tall and 3 units wide, or it has 2 rows and 3 columns.
Each number, which can even be a variable or equation, exists in the positions of the matrix. When we refer to an element, for example, A sub ij, so the letter A with subscripts I and j in a simple matrix, it's referring to the particular element in row number I and column number j. So the first number indicates the row, second one indicates the column. And I and j are of course integers because they represent an index. So there are always m times n elements in an m cross n matrix, and I refer to the element A. If I refer to the element A sub ij in this matrix, I is a number between 1 and m, and j is a number between 1 and n.
Also, a vector has two definitions. Now, a vector is a mathematical quantity with both magnitude and direction in space. Now, as you may recall, a scalar is a quantity which only has a magnitude. However, a vector also has direction.
What's the second definition then?
Now, wait, it is a 1 into n column. Now, it can be thought of as it having only one column but n number of data.
So you're saying it's a 1 times n matrix in reality?
Yes.
So, okay, one column and n number of rows. These are crucial, especially in physics. Position, velocity, force, jerk, these are all types of vectors, as you may recall from their definitions as vector quantities. Vectors can be multiplied by scalar values, which are simply constants. And when you multiply a vector or a matrix by scalar quantity, this will change their magnitude as such as scaling it up, as the name suggests, but not the direction in space. Their applications are limitless due to many interesting properties, but mainly two properties: the operations known as dot product and cross product, which is exclusively for matrices.
Now, the scope of vectors is very huge. So, we'll link extra resources and materials in the transcript below.
Finally, let's look at the interactions of matrices and vectors. Ever heard of transformations? That's exactly what a matrix does to a vector. Matrix vector multiplication can lead to translation, stretching, compressing, and reflections. Along with the scalar, dot, and cross products, matrix vector multiplication is the other major skill to know within this area. It's like flipping the vector on its side, multiplying and adding the components, but more about that as well in the transcript. Thank you for joining us along on this journey into matrices and vectors, and we hope the transcript will be helpful as well.
Thank you guys. See you in our next episode about algebraic and differential equations.
Just one chota sa error happened. I said matrices instead of vectors in one place, but we'll just say vectors star in the subtitles.